So we are actually looking at the components of an assembly program, whereby when we look at an assembly program, it consists of three components: the assembly directives, assembly language instructions, and commands. That is what we saw yesterday. This is a complete assembly language programming, which consists of three assembly directives, which are not assembly language. They are only visible here when you actually type on your MPLAB IDE, and those assembly directives controls the flow of the program or includes or the structure of the program. So for example, as I mentioned, the hash include, it includes a certain file. So hash include is an example of assembly directives. It directs what are the things to be included in the program and where should the program end, for example. So this is one example of assembly directives, and another example we saw is END. The second component is the assembly language itself. Of course, you can see all those fonts in dark blue, bolded dark blue. They are all assembly language. And the third component is the commands. Whenever you put semicolon, you can actually add a command, which is not a compulsory element, but it will be good if you can comment your programs. Any question up to this point? That's what we learned yesterday. So that is when we look at an assembly program. Now next, let us look at the elements of an assembly language statement. So what it means by an assembly language statement. So an assembly language statement has four elements: label, mnemonics, operand, and also command. So every line of code is known as one assembly language statement. Every line is known as one assembly language statement. So in one statement, assembly line statement, there can be maximum up to 4 elements. So the first element is label. So in this highlighted statement, we have all 4. This is actually label. It's a label field. And then you have, what's the second field? Mnemonics. Mnemonics are nothing but the assembly instruction, right? Or the opcode, the mnemonic representation of the opcode. And the third one is operands. So what is operand? Operands are the input parameters for the opcode, right? So those are operands. And what is the fourth one? Command. So this is the fourth one, which is command. So each one of these elements, you can look at it as in the form of columns. So the first column is always kept for label. Second column is always kept for mnemonics. The third column is always for operand. And of course, the fourth one is the commands. So maximum in one statement, you can have all 4. But minimum in one statement, you can just have only one, which is the mnemonic minimum that you can have. So any question up to this point? So just for your information, it's not going to be asked in tests and things like that. So let's go to the next one. So let us look at each one of these elements. First one is the label field. It must start from column 1 and followed by a tab, space, colon, or end of line. You know what's end of line? Enter. So each one of these elements has its own requirement, that it must start from the first column, right? And must be followed by a tab, space, colon, or end of line, which means for the compiler to know where is the label, you should at least use a space, or you can use a colon, or you can use the end of line, or a tab. So when you space between the start and move F, the compiler can identify that, okay, the first one is the label field, and the second one automatically. So this space helps the compiler to know whether it's this label, is this mnemonic, is this operand. But of course, command, it doesn't even register, because that is just for us programmers to write. Are you all following? Now it must start with alphabetic character or underscore. Alphabetic, it's not alphanumeric. So you have to start with this. If you put number, you see it turns red. So you have to start with alphabetic. But you can start with underscore, no problem. But in between, you can have number. This is starting only, shouldn't have that. May contain alphanumeric, underscores and question mark. So in between, like this now, how I showed you, can contain alphanumeric, underscores and question mark, and it can go up to 32 characters and is case sensitive by default. So if you're using label, the label, if you use capital S, then you should use capital S. It is case sensitive. Now here, if you look at this program, you can see that the label always comes in pair. Whenever you are putting a label here, what you are doing is you are tagging this instruction with this label. That is what you are doing. Are you following? So, let us look at, before we proceed further, let us look at program memory. So this is program memory. We are going to look at symbolic. Let me just adjust it here. So what I'm doing is, this is program memory. We can view the content of program memory. So let me just quick build this. Okay, the moment I build this, do you see suddenly program memory have all this? So what is this green line stands for? Program counter. So now, let's go to the simulation mode. So when you go to simulation mode, you can see at the bottom of the screen, it is MPLAB sim. So we press F6 is a short, sorry, I have to use function. So when it's F6, do you see the program counter is pointing at which address? Address 1. What is this? This is the line. This is 0, 0. Why is it pointing at this address? Yes? What's another name? It's a reset vector, right? So by default, the PC will be pointing at address 0, 0. But here you look, the PC is pointing to go to start. Why is that so? Now, when we look at the program memory address, you know that 0, 0, 0 is actually the reset vector. And then, if you look at the chart back, there is this address 00008, which is reserved for high priority interrupt, and 0018 is reserved for low priority interrupt, right? Are you all aware of that? So here is 0, 08 is here. From 08 until 18, this whole portion from 08 until 18, this whole thing is reserved for interrupt, which you will learn in chapter 6. So for now, we will just leave as it is. So meaning to say, in other words, you cannot write any instruction here. And then at address 18 is actually reserved for low priority interrupt. So in other words, from 08 until 18, it's already booked for other purposes. So you can't write instruction from address 0, right? Because when you write instruction, after that then 08 until 18 is reserved. So you can't store much instruction here, right? This one, EF0D, how many bit is this? EF0D, how many bit is this? This is 16 bits, right? Do you see the address are skipping by 2? So why is that so? Why is it skipping? Yes, not 32 bit, 16 bit. One location can only store 8 bits, right? So if you look at the opcode hex tab, you see the address is 00, then 02, 04, 06, skipping by 2. Why is that so? Is when you see this instruction, for example, EF0D, the 0D is stored in which address? 00. Always remember the lower byte is stored at the lower address. The 0D is stored at 00. EF is stored at 01. That's why the 01 is not displayed. And then 02 is 00 is stored 02. F0 is stored at 03. You understand? So that's why it's actually skipping by 2. So this is 16 bits. 1 byte is stored at one address location. Any question up to this point? Able to follow? So meaning to say here you can only have 1, 2, 3, 4 instructions only you can write. After that, from 08 until 18 is all reserved, right? Then of course you can write by. So because of this reserved portion, the normal practice is to start writing instruction after 0018. So because 0018 is reserved, so after 18 is what? 1819, what is the next address? 1A. This is 1A, right? Do you see 1A is where you start to have the instruction? Move WF, ADWF, move WF. Is that okay? So then conventionally, normally we will start to write our instruction after the reserved area, 08 and 18. You will learn how to use this when it comes to chapter 6. But for now, take note that you can't write your instruction from 08 until 18. So 18 means 18 and 19. Nah? So after that is free. So the actual address that you are able to write your instruction from is 001A. So which means at 001A is where your actual first line of the program starts. Alright? So how do you want to make sure that when you reset your microcontroller, the PC automatically goes to address 0? But our first line is at 1A. So how do we want to make it to go from here, come to here? So we use this particular instruction, go to. Go to instruction is a control instruction. We will see the control thing later on. But go to is always followed by a label. Now before that, this ORG, it means origin. So this org is an assembler directive. It's an assembler directive. We will learn later, but I'm just telling you beforehand so that you can appreciate what's happening here. Org stands for origin, and it is followed by an address. So when you put origin hex 00, after the origin line, it should always follow by an instruction. So when you put origin 00, what it means is that the next instruction that you write, this is the first instruction that you write, will be stored at this address. Or meaning to say, the origin of this instruction is at address 00. Are you able to follow? Remember that this is not instruction, this is assembly directive. This is instruction. This is instruction. This is instruction. But when you put origin hex 00, what it means? The next instruction, it is stored at this address. So that is why at address 00, what do you see? Go to start. Now whenever you use label always comes in a pair. And you see that the green arrow is not pointing at org hex 00. Why? Because org 00 is not an instruction, it's an assembly directive. So here you can see much more clearer that the PC is actually pointing at address 00, which is pointing at go to start. When you execute this instruction, where do you think your PC will go? So, do you see it goes to start? So that's how label works. You have the pair and you use go to instruction. There's two instructions actually, go to and also branch. We will learn branch later, but it has the same function. So go to followed by a label. So when you execute that, the PC will go to that label. So where is start? It is here. So automatically, now your PC is pointing to the first line of instruction, right? So this is how, even though there are some reserved portion in between, when we use this go to start, when we start the microcontroller, it automatically will start, go to start, and then it will start the instruction and execute the instruction. Is that okay? Any question up to this point? Anything that is unclear? So you can see under the label column there is start. So what if I put start somewhere else? Now accordingly you can see the start label is now tagged or labeled to ADDWF. So if you execute this, where is it going? It is going to start, but that is not the first line of our instruction, right? But here I'm just trying to show how the label actually works. Is that okay? Any question that you all have? Okay, so that is why you always, henceforth, you always need to have this portion in your program. So this portion will always ensure that automatically the PC comes to the starting or the first line of a code. So when you put label here, this label is like as if it is attached to move F. It's like label, right? It's labeled to that particular instruction. Any other question up to this point? Excuse me. So that is label. The next field is the mnemonic field. So the mnemonic field can be assembly instruction mnemonic, or it can be assembly directive. So the mnemonic field is always which column? The second column. So if you look at the second column, and also if you practice, do you see that whenever this is a very good practice, if you can always follow something like this, looks very neat. Label is on the label, first column, second column, third column. So it's very visually, it's very easy for you to see, and if there's any errors, also visually it's very easy for you to identify. So this is the second column, right? So second column can either be the mnemonic, or it can also be assembler directive. For example, ORG, this is one we just saw, right? Or it can be end or include. Is that okay? So it must begin in column 2 or greater. So how do you separate column 2? At least by a space minimum. Well, I like to use tab to keep it same neat. Is it not visually nicer to see if you do like this? So it must be separated from the label by colon, one or more spaces or tabs. That's what we just showed this now. How to actually separate. Right, we have done this already. The third is the operand field. Any question? So the operand follows the instruction mnemonic. So the instruction mnemonic always will need some input parameters, right? So it provides the operands for the instructions or arguments for an assembler directive. So if the second column is a mnemonic, assembly language mnemonic, and then this one will be the parameters, the input parameters for that mnemonic. If you're using assembler directive, this becomes an argument. Argument, another word, you can also say notified. It's also like an input for the assembler directive. Multiple operands are separated by commas. So you can see here, you have multiple operands. And how do you separate them? Commas. So you don't have to put space after the comma. It's not like Word, it won't give you the correction, grammar correction underneath for formatting and things like that. So just put comma, and this will help the compiler to actually identify, okay, what is what. Any question up to this point? And then the final one is a comment field, as I mentioned. Comment field is purely for you, for the programmers to program. Do you see when we put main program, does it appear here in the program memory? Does assembler directives anywhere get displayed here in the program memory? No. Only the instructions only. So at least the assembler directive controls certain function of the programming. For example, whenever it says end, the PC will stop. One example. But the comment, it has no effect at all. It's just purely for documentational purpose. So just take note that the comment starts with semicolon. All characters to the right of the semicolons are ignored by the assembler. Comments provide documentation to the instructions or assembler directives. Comments may explain the function of a single statement, the function of a group of instructions, just as I mentioned earlier, the earlier example. You can give comment line by line. Move the content of hex 10 to working register, add the content of working register to hex 20 and store in working register, move the content of working register to hex 30. That is line by line. Block comment is add the content of hex 10 to hex 20 and store at hex 30. It also serves the same purpose, right? So many ways of doing, but comments help you to understand things better. So with that, next thing is we're going to look into assembler directives. That is one of the first component of assembly language programming, right? So there are several types of assembler directives: control directives, data directives, listing directives, macro directives, object file directives. Some of them we'll use, some of them we don't use. So we will see one by one. So the first one is the control directives. So the control directives has this particular format. If you give a particular expression, you can execute something else and if. So this is the syntax for control directive. So let us see, do I have control directive here? Oh, I don't. Oh, I have. So this is the format. If you give a particular expression, you do something, else you do something, and then you end the if expression. Is that okay? So here, sorry, this is a start. Remove this. And I'll remove this. I'll put NOP here as well. I just purposely putting NOP so that we can see where the green arrows are going. So here we have a variable here, but we have to declare this version. So usually this will be known as data directive. So let's say we have this version. So let's say we use the assembly directive EQU, which stands for equals to x10. So I'm using a constant, I'm declaring a constant version. So where am I writing this version at? Which column? Which column? Column 1. Column 1 is label. And then I'm using column 2, I'm using EQU, which is an assembly directive. And then column 3, I'm equating to a value. So can you make sense what this will do? So what this means, version, wherever I write version, the version is equals to x10. Is that okay? Yes. Equal. This one. Oh, this one. This is expression. If statement requires expression. So expression you can use version is less than or more than, equals, not, same, things like that. But here when you are defining a particular label, then you need to use EQU. So version is equals to x10. Is that okay? This one we will actually learn later, but this is quite simple to understand, right? EQU means version is equals to x10. So when now we are using, our focus is on the control directive. Control directive means what? This instruction controls the flow of the program, right? If it fulfills this requirement, it will execute this. Else it will execute this. Is that okay? So here, just for the sake of simple understanding, we will just use x10. So, and here we will use x26. Is that okay? Let's quick build this. So on the defining part, of course, I will share all this code in Telegram, so don't have to worry. So now when we, okay, let me just include another thing. Because we want to see which action is happening, so I want to watch the content of working register. So we can go to watch. How do we add working register? So you can search for working register, just type W. Then you add that SFR. So currently the content of working register is 0. So you can just put it here. So just see how am I doing so that you can also use the same step to actually check what is happening. So now when we press step by step, sorry, I'm doing the wrong thing. Function F7. Okay. Now it is pointing at no operation. So the next thing, which instruction do you think will get executed? Move LW10 or move LW26? There, you see it's pointing at move LW10, right? And it executed that. So this, you see, if else, it controls the flow of the program. So, but what if it's not equal? Decimal 10 and hex 10 are not the same, right? So let us try to build this back. So where do you think it'll go? See, it's good. It went to the bottom one. It go to 26. Is that okay? Any question to this point? Quite seldom we use this, but I'm just showing you how this control directive works. So that is control directive of if, else, and if. So they've given an example here, but we have done one. All this we don't use. Another one is hash include, which I have already explained earlier. It is to actually include a particular file. So for example, we have used this, right? Hash include, which you can see here on top. So according to the microcontroller that you're using, you have to specify the exact model number. And inside this file, where it contains all the special function registers, addresses, and all the predefined things. So because of this, that's why you can straight away write WREG. If you do not have this, then you try typing WREG, it will say unidentified. It's unable to define what is WREG. So that is hash include. So this is compulsory, you must put in your programming. But for test purposes, you don't have to write hash include. For test, you just need to write from here onwards. Is that okay? Next one is radix. So radix accepts one argument, which you can set what is the default radix. So it sets the default radix for data expression. The default radix here, under the default radix, what you can write hex, you can write decimal, or you can write octal. So how do you write? You write something like this, radix decimal. So what it means, let's see, do we have radix example here? Oh, yes, we do. So what this radix will do, I'm going to use the same example. So the radix you should specify on top. So you write as radix, and then you define. Let's say you put decimal. So when you write like this, radix decimal, any number that doesn't have a prefix will automatically be decimal. So now I put in radix decimal. So of course, and purposely version I put equals to 10. So here's version 10, definitely is going to execute this one. But here, when we just put 10. So when you put radix decimal 10, what is this? This is decimal. So let's check it out whether it's correct or not. So we can clear this. Back here. Yes. F7. So definitely it's going to go to move 10. But this is, the radix is decimal 10. So DC becomes 0E. What if you don't put any prefix? What's happening? So remember earlier I mentioned that in MPLAB, by default, if you put any number without any prefix, it will take it as hex number. Hex number by default. If you don't put any prefix, it will take it as hex number. Now when you put radix, if you put radix, any number that doesn't have prefix will become decimal. But if you put prefix, does this still become decimal 10? Always remember, prefix always has the highest ranking. Any number that doesn't have prefix will follow the specified radix. Is that okay? So you may ask then, where do we actually use this? You may ask a question like that. So sometimes, usually we'll use as for radix decimal. So for hex, commonly we like to write with hex in front, right? But let's say if you want to write decimal, you just can write 26. And you know, because of radix decimal, this will be decimal 26. Of course, you can write D single apostrophe and close. But if you have a lot of decimal numbers that you want to deal that way, then better to use radix decimal. And all the hex, you write prefix, and all the decimal, you don't have to write prefix. So it will be easy for you. Is that okay? So that is radix decimal. So while we don't really use this. So that is all that we cover under control directive. So the next is data directive, which we will continue next week. Any questions up to this point?